Hello and a very warm welcome to you. A couple of days ago I published this video in which I asked Anthony Riley, aka Sleeping Warrior, if he would answer a couple of questions relating to his rather crazy idea that relative density is all that's needed to explain why objects fall towards the Earth. And he appears to believe that gravity doesn't exist. Well, it didn't take long for Anthony to actually publish a reply. He didn't bother to tell me that he published a reply, which is a bit odd. And he took a bit of trouble to build a thumbnail for his reply, which is a little abusive, really rather unnecessary, Anthony, especially as you're aware of my recent medical scare. Oh well, I'm not going to let that bother me. Let's see whether he answered my questions. So my first question related to this block of wood that I'm holding. Now, Anthony claims that all you need to know to determine which direction the block of wood will fall when I let go of it is the direction of the more dense medium. The block of wood is being held in the air, probably about 3 or 4 feet above the ground. The medium all around that block is exactly the same density. There is no difference in the density above or below or to the side of that block of wood. And that density of that medium is essentially exactly the same all the way down to the ground. There's pretty much no difference in the density of the medium of the air between 3 foot above the ground and the ground. It's all the same density. So the question is, which way will the block fall, and how do you know that, given that the density of the medium all around that block is identical? Okay, so let's find the part of Anthony's video where he thinks that he answers this question. He sped my video up in his video, which is why I sound a bit like one of the chipmunks. Exactly the same. Can Mr. Riley predict which direction this piece of wood will move when I let go of it? So if I've got Anthony's claim correct, and please correct me if I'm wrong, Anthony, the block of wood should fall towards the more dense air.
Yeah, the block will fall towards the more dense, because the block of wood is more dense than the medium it's in. So it will fall towards that, it'll fall in the direction of the more dense medium.
Oh dear, it appears that Anthony doesn't understand the question. There is no more dense medium. The medium is the same density all around the block. So how can it fall towards the more dense medium? Let's see if he says any more. However, the density of the air all around that block is identical. I defy anybody to measure a density difference in the air around a similar sized object. And I could go to a smaller object and make it even harder for you. So in this particular example, Anthony's determination of direction simply doesn't hold up. And as we allow the video...
Whoa, what do you mean my determination of direction? It's just going to go towards the more dense medium.
But Anthony, there isn't a more dense medium. The medium around the block is the same density in all directions.
We need a definition here, don't we? So relative directions, Miles. The most common relative directions are left, right, forwards, backwards, up and down. Relative to what? Do you think that might be, Miles? Yes, you're making the same mistake that Bob Nodell makes, which is that he thinks there's an absolute up and an absolute down. And that may very well be the case. However, all directions are relative to the human because they are humanistic, right? So that's why your left is my right, and the Australian in antipodal position to us in Australia, his underneath his feet is my underneath my feet, but they're not the same, are they? They're relative, Miles. Up, down, left, right is relative. So back to your video, this is going to go in the direction of the more dense, wherever the more dense is. I've got a feeling it's going to go up.
Oh dear, you really don't get it at all, do you? There is no more dense medium. There is no direction towards the more dense medium here. Whatever direction you choose, the medium density will be the same. So how do you know which way it will go? Go to play on. You can see that the block of wood does not fall downwards on the screen because I've positioned the camera actually at an angle so that the block of wood will fall in a different direction diagonally towards the bottom right-hand corner. Anthony had no way of predicting that using his methodology.
I did. I predicted it to the more dense medium. It will head in the direction of the more dense medium.
You keep saying that, but you don't know. There is no direction with more dense medium. The medium is the same density in all directions. Now, I'm expecting Anthony to cry foul at this point and say that I wouldn't be able to predict which direction this block would fall, or if he did a similar test, I wouldn't be able to predict the direction that the object would fall. And to which my answer would be, of course I wouldn't. And that would be the first thing I would say. The information in the picture does not give me enough information to tell you. Tell me which direction the centre of the Earth is, and I'll be able to tell you which direction the block will fall. Now, you can't ask for the same information. Your claim is that the only thing you need to know is the relative density of the object and the density of the medium surrounding it. But you don't need, that isn't enough information to tell you which direction the block will fall. You need more information. You also need to know the direction to the Earth.
No, I just need to know the direction for the more dense medium. Which direction is the more dense medium? Because numbers are scalars, Miles, and they are linear in nature. In the same way that 1, 2, 3, 4, 10, that goes up in a number. Up isn't a direction in numbers, is it? It's the term that we use to describe going up in numbers, but it isn't actually a direction. So, whilst you're right to point out that you couldn't identify the direction because you need to know the centre of Earth that doesn't exist, I wouldn't be able to do it either on the information because I don't know the direction in which the more dense medium is at. Because you've played funny buggers to make it indicate or appeal to your own audience that I need more information, notwithstanding the fact that you need more information too.
Well, I've got no idea what all that stuff about numbers was supposed to mean. But this is the whole point, Anthony. You claim that all you need to know is the density of the medium and the density of the object, the two relative densities. But that isn't enough to tell you the direction.
So anyway, let's carry on. I don't really see how that benefits in any way whatsoever, Miles. More dense, less dense, not up and down. More dense, less dense, that's the direction. It's calculable as well. Not that my calculations make any difference in science, but let's go.
Well, yes, of course it's possible to calculate the density of things or to measure the density of things, but the fact remains that in this particular example, the density of the medium is the same all the way round the block, and you can't tell which way it will fall without more information. So he seems to have completely misunderstood and failed to answer my first question. So let's see what he manages to do with my second question. So my second question for our sleepy friend was for him to explain why the block of wood in this Pyrex bowl half filled with water, why does the block of wood, which has a density that is less than the density of the water, sink roughly 50% into the water and then stop sinking? According to his relative density model, because the block of wood has a lower density than the water, it should come to rest on the surface of the water. But it doesn't. And I showed a couple of other pictures, one of a duck also floating on water, although roughly 50% submerged, and also an anvil partially submerged in mercury. So how does relative density explain this observation?
Miles wants an explanation for why it is that this mass is partially submerged and why it is that the duck is partially submerged. And of course the answer is mass.
By Jove, I think he's got it. Yes, Anthony, it's to do with mass. Look, Anthony, there's one mass, and there's another one. I really think you might be onto something.
As you stock mass on top of mass on top of mass, you are going to create more weight, and I use the word weight in its colloquial sense that's been hijacked by current physics. I am not using it in the context of mass times little g. Little g doesn't exist. So as with buoyancy being out the window now, we also know that weight, in the physics sense, the mass times the acceleration due to gravity, well, the acceleration due to gravity is out of the window.
Oh dear, I really thought he was going to get it there. And then he starts whittering on about how buoyancy and gravity aren't real, they're thrown out the window, all because he doesn't understand what a fictitious force or pseudo force or inertial force actually is. Anthony, go and do some reading and learn about it.
So you're left with mass. So if you stack more mass on top of these things, and it starts to push below the surface of the water.
That's right, Anthony. More mass means more force. You used the word push instead of force, but you still haven't explained where any of the push actually comes from in your supposed explanation.
What might be doing that if we've not got gravity anymore?
Well, you're still a long, long way away from demonstrating that we don't have gravity anymore, but I'll go with this because I want to hear what you think might be doing that pushing if it's not gravity.
Well, you're only left with mass, Miles.
That's right, we're left with mass, but mass alone doesn't provide any push, any direction, any force. So what's providing the push?
And as we can see, you're adding more mass to the original mass, and it's applying a commonly understood term called weight.
Yes, I'm applying more mass, but I'm not changing the density of the wood. The wood is the same density. Now you start talking about weight, and earlier you tried to wriggle out of weight actually being a function of mass and gravity. That is what weight is. You can't simply redefine weight to suit your own purpose and use the word. If you're going to ignore the gravity component of weight, then all you have is mass.
Not mass times little g, just mass.
Not mass times little g. So just mass then.
So you've got the water, the resistance, the inertia of the water pushing against the wood, and you're just adding mass on top of it, Miles. That's all you're doing.
By Jove, I think you're going to get it. Any second now, you're actually going to get it. Yes, Anthony. All I'm doing is adding some more mass.
With regards to the duck is only partially submerged because the duck's got mass.
Yes, Anthony, that's right. The duck's got mass. You're so nearly there. Just a little bit further now.
In the same way that Einstein states that the effect of the curvature of space-time is caused by the uneven distribution of mass.
No, Anthony, you don't need to use Einstein or understand what Einstein said in order to get this. It's not that complicated. But yeah, okay, Einstein did say that.
We see the uneven distribution of mass here, on Earth's scale. But the effect is not the curvature of space-time. The effect is the relative density, and in this case, disequilibrium.
But Anthony, the density of the wood doesn't change even when I add another piece of wood. And everything achieves equilibrium. It's not disequilibrium, whatever you mean by disequilibrium. And you still haven't explained what forces need to balance in order to create that equilibrium.
Because you've got the water that's pushing back against it.
Pushing back against what? You haven't said what's pushing down.
Because water has mass and it therefore has pressure pushing against the sides of the walls of this container. That mass pushing against the walls of the container is a force by virtue of its own mass, and that force per unit area is pressure. So there is a resistance pushing back against the blocks of wood, Miles.
Well, okay, the water's pushing back against the wood if you want to think of it like that. But there must be something pushing the wood down, because if it wasn't, the water pushing back against the wood would mean the wood just sat on the surface of the water.
Now, I know that you don't understand this, and you're going to claim that it's simply word salad, but it's your own physics.
Nobody has their own physics. There just is physics.
Removing the nonsense that you lot believe in the acceleration due to gravity. Strip that back because it doesn't exist anymore and hasn't done since World War I, and you're left with mass. Well,
That's right, Anthony. Just mass. Relative density doesn't come into it at all.
we have mass giving pressure inside the container. Interesting that it's done inside a container, Miles, for you to be able to utilise to demonstrate the point. Could you imagine trying to do it without a container? That pressure wouldn't exist, would it? Bit like gas pressure requires a container mass. Miles, good demonstration, by the way, for containers to give you pressure.
Well, if my Pyrex bowl is a container with an open top, then I guess this must also be a container. So you can have gas pressure in a container. Thank you, Anthony. Big Blue's going to be thrilled.
The pressure pushing back against these three pieces of wood is essentially an inertia. It's a fall arrest, isn't it? It's stopping the objects from finding their own equilibrium because all these objects are more dense than the medium that they're in. So don't forget about the medium that we're in. Let's call it 1. You've got this block that is, we'll say it's 100, and that one's 100, and we'll say that one's 200. So you've got a relative density disequilibrium there of 400 for the wood, and you've got like 1 for the medium that they're in. But you've got the water underneath. And we can see that the water underneath is more dense because it's holding back this mass above it. So we can tell that these blocks, even though you're stockpiling them on top of each other, we can tell that they are still less dense than the water, but they are partially submerged because of mass.
Yes, Anthony, that's right. It's because of mass, not because of density. Oh, you're really not getting this. Let's look at the whole thing again. I place a piece of wood carefully into the water. The wood is less dense than the water. It doesn't rest on the surface of the water. If density was the only thing happening here, the only thing applying was a relative density, then you would expect the wood to sit on the surface of the water. The less dense thing would sit on the surface of the more dense thing. But it doesn't. It submerges about half its height. When I add more pieces of wood, I do not change the overall density. The density of the wood is remaining constant, but the wood sinks further into the water. Now, you're right to say that there's an equilibrium going on here. There is a balance of forces. Force that is pushing down is balanced by a force pushing up. The explanation in terms of physics is that the pseudo force or inertial force or fictitious force of gravity is balanced by the buoyant force, the buoyancy force. And so the objects float. And all that's needed, all that you need to know for gravity is in the formula that I've shown you from Newton. It applies on Earth absolutely perfectly and can be deduced apparently from Einstein's equations. My maths isn't good enough to do it. Where mass and the distance between the objects, so the mass of the wood and the mass of the Earth, the distance between them are the only things that matter. They result in a force which pulls the wood down. There's a buoyant force which is calculated by knowing the density of the medium, the water, and the amount of water that is displaced by the wood, and also acceleration due to gravity. And the buoyant force and the gravitational force cancel each other out, and so the wood remains floating, partially submerged. My question to you is, how can you explain this in terms of relative density? Your claim is the only thing we need to know is the density of the wood and the density of the medium, the water, maybe the density of the air as well. How can we explain this only in terms of relative density? If you can't explain it only in terms of relative density, then it's clear you need something else. The same applies to this anvil being floated in mercury but partially submerged. So Anthony, the question is still there for you to answer. You haven't yet answered it.
That's your answer, Miles. It's not that difficult. You just got to think. I know you struggle thinking laterally, but remember, there is no science for a flat Earth. So all of the science is geared towards the heliocentric nonsense. So we have to come up with terminology so that we can convey the real world science with the Mickey Mouse science that you guys push, the pseudoscience nonsense.
Okay then, give me the science. All you have said so far in this video in response to my questions is just due to mass. That's what the currently accepted scientific explanation says. It says it's due to mass, the mass of the wood and the mass of the Earth. If you have an alternative explanation, a flat Earth science explanation, please give us the science. Please explain how relative density explains this. If you need something else, and relative density isn't the only part of your explanation, your equations or whatever, then fine. Tell us what it is. Explain it. Don't just say it's mass, then say it's weight, but I'm not talking about real weight, I'm talking about some colloquial use of weight. Give us some science, Anthony. Give us some measurements, give us some real description of what's going on, maybe even some experimentation that will show and explain what you're looking at here in this simple image that is beautifully, concisely and perfectly explained by the physics of buoyancy and gravity, whether you use Newton's equations or Einstein's.
I trust that sufficiently answers your question, Miles. But
the fact that you think that you have answered my question just shows how little you understand. You've got nowhere near answering it. Now, your video goes on for quite a bit longer, but I think I've already used up quite enough time. Hopefully, if you watch this, you will, and I can't post a comment on your channel to let you know because I'm blocked, I presume. But if you watch this, you'll realize, I hope, that you haven't even come close to answering the question. Either question. So perhaps you give it a little bit more thought and respond, and let me know you've responded with some better answers. So I'll leave it there. Thank you for watching, and I will play just a few more seconds of Anthony's video because, well, once again, he gets so close to getting it right.
No doubt you'll be unhappy with it, but I'm free to and happy to welcome you to Emma UK's Discord server. I might even put you a link in the chat. But, Miles, this does address your question. The reason why they are partially submerged is mass. The pressure caused by the walls of the container that the water sits in is pushing back against these bricks, these timbers. The answer is mass.